So the question says, suppose that the money demand function is this, MP equals 800 minus 50. Yeah. And don't forget, equilibrium in the money market is when money supply equals money demand. So R is the interest rate in present. And then money supply is 2.4 when the price level is fixed at 6. We are going to be graphing the supply and demand for real money balances. We're going to be looking for the equilibrium interest rate. Basically, these are what, okay, we'll be doing under this question. So the first question says we should graph the supply and demand for real money balances. So to get that, we have to like get our rates when money supply equals money demand, and we're going to be getting a value for our money supply and money demand. So to get this, we're going to be equating money demand and money supply. Money supply equals this is just basically saying okay, money supply over price. Then an money demand equation is 800 minus 50R. So we have our money supply to be 6 to 4, and then our price to be 6. So we're going to press to 4 over 2. So we have 400 plus 800 and 50. So 400 minus 800. We're just basically collecting lifetimes here. Collecting lifetimes. So we're trying to make our reciprocal formula. So we're looking for the rate. So yeah, 400 minus 800 equals minus 50R. Minus 400 equals minus 50R. So my R equals minus 400 minus 50. My R equals divided by 50. Equals 8. So this is my rate. My rate is 8. So when R is my rate, I'm going to be getting the value for my money supply and money demand. Here, I've gotten the value for my money supply to be 400. Money supply equals 400 as per 24 over 6. Divided by 6. How do I get my 400 here? Then, to get my money demand, we are giving 800 minus R. So, so yeah, my money supply is 400 and my money demand is also 400. So to plot the graph, my rate is 8, money demand equals 400. Okay, so this is my money demand, money supply, and this is my rate. And we have it as the rate. To plot the graph, we're going to be 100, 300, 700. Then these numbers are just basically assumptions. As for okay, we have 400. So I mean, we need 400. We have to be able to close the graph. Then here we have 3, we have 6, we have 9, we have this is my rate. So we're going to for this we're also going to be getting the intercept for our. So here we have our rate to be 8, our money demand and money supply to be 400, and we have it. So here I'll be this is my money okay. So this is for the money supply. Yeah, for the money supply. The money supply is fixed, so it will just be fixed at 400. My let's assume it to be here. I'll put here. So yes. So the slope for the LM curve is meant to be. I'm supposed to have something like this. So in order to achieve this, so we're going to be getting my money demand to this money demand. Hmm. The slope for money supply is fixed. So I mean it should just be there. But here we're going to be working with our money demand. So our money demand curve is going to be like this. And the question we're giving money demand to be 800 minus 50 R. So when of course when R is 8, money demand and money supply is 400. Then when R is, let's start from 3. When R is 3, when R is 3, money demand equals 150. When R is 6, money demand equals 800 minus 50 into 6, 500. When R is 9, we have 350. And when R is 10, we don't really need that. We have 200. Okay. So when R is 3, money demand is 650. We don't have 650, we have 600. So obviously I don't have 650 there. When R is 6, our money demand is 500. Okay, we have 500. When R is 9, we have 350. So we don't have 350. So we are doing 350 there. Okay, we don't really need that. Then when R is 12, 200. Mind my drawing. Okay, okay. I made a mistake. It is supposed to be somewhere here, and it is 400. 9 is with 350. So this is again. Okay, so the next question says we should look for the equivalent interest rates, but we've gotten that here the equilibrium interest rate. They said what happens to the equilibrium interest rate? Okay, that's the equilibrium interest rate. Equilibrium interest rate is 8. The next question says what happens to the equilibrium interest rate if the supply of money is reduced from 2.4 to 1.8? To do that, money supply equals money demand, as I've said earlier. So to do that, we're going to be creating our money supply to money demand because our initial supply of money was 2.4, then it has been reduced to 1.8. So we're asked to look for the interest rate at 1.8. So yeah, that's what we're doing. 1.8 divided by 6 equals 800 minus 50R. That's 300 equals 800 minus 50R. Then we try to make 50R the subject of the formula, make R the subject of the formula, then we get our new equilibrium rates. So R equals 10. That's the new equilibrium rate. So this means for the central bank to reduce the supply of money to one is they have to increase the interest rate. Because our initial interest rate when the money supply was 2 4 was 8%. Now we have 10%. Then the next question says if the central bank wants the interest rate to be 5%, what money supply should it be? So now we'll be looking for the interest rates. This point, so interest sorry, we'll be looking for the money supply. Interest rate is 5% and money supply is what we don't know. So we do our normal money supply equals to money demand and the money supply is 2 4. So we're going to be doing yeah. We don't know what our money supply is. Sorry, that was a mistake. We don't know what our money supply is because that's what we're looking for. So that'll be money supply divided by 6 equals 800 minus 50 into 5. Yes. So that's money supply divided by 6. That's the price level according to the question. So that's 800 minus 250. Then we collect like terms, then try to make M the subject of the formula in order to get our money supply using 5% interest rate. So when our interest rate is 5%, we have our money supply to be 3,300. That's an increase in money supply because interest rates is now less than 8%. You can remember when it was at 8%, we had to fall 10%, we had oh I can't remember, I think we had one something. Then now at 5% we have okay. We have that too, yes. Yeah, we'll be moving on to the equilibrium in ISL model. Yeah, it's just basically saying we're joining IS and LM together. And since the IS curve represents equilibrium in the goods market and LM curve determines equilibrium in the money market, the intersection determines the unique combination of Y and R. Y is output and R is A that satisfies equilibrium in both markets. So that's the LM curve, that's the IS curve. Then we have our equilibrium at R and Y. So yeah, that's what we're basically doing here. So equilibrium in the ISLM model, intersection of the IS and LM curves are at this point. The goods market is in equilibrium. Planned access to the expenditure equals output. That was a mistake, sorry. It means we planned expenditure equals output. And the money market is also in equilibrium, meaning money demand equals money supply. So we have equilibrium in the ISLM model when the planned expenditure equals output and in the money market when the money demand equals money supply. So note the equilibrium interest rate and output depend on factors like government spending, taxes, money supply, and investment. Changes in fiscal policy, for example, government spending shifts the IS curve, which is a good market, while change in monetary policy changes the LM curve, like shifts the LM curve as money supply. So we're going to be solving this exercise. Okay, so the question says consider a given economy characterized by the following. We have a consumption function, we have investment function, blah blah blah. So to solve this equation, we need to get the output function for both IS and LM. So for the IS block, um, for the IS block, we have y equals c plus I plus g. We've solved the equation on that before, so I don't expect this to be new to you. So we're going to be imputing our consumption function, our investment, and government expenditure for us to get our output function for the IS block. So we have y minus t. Our t is that's our tax, and we were given tax to be this 500 plus 700 minus 800 r plus 500. Yes. So y equals 300 plus 0.6y. So we're going to be multiplying 0.6y with the numbers and variables in the bracket. So that will be 0.6y, and 0.6 times 500 will give us 300 plus 300 minus 800 r plus 500. So we're going to be collecting like times. 0.6 will be going to the other side because that's y. So 1 minus 0.6 you'll be giving us that's 0.4y. Yeah. So then we're going to be dividing through by 0.4. That's 3000 minus 200 r. So we've gotten the output function for the IS. So now we're going to be getting the output function for the LM, which is the money market. Yeah. So for LM, for the LM block, money supply equals money demand, and our money supply is 3000, but our money demand is y minus 200 r, and we have our price to be 3, so that's 3000 divided by 3 equals y minus 200 r. Yes, 3000 equals y minus 200 r. Okay, so now it's moving y to the other side. So y, okay, that be 1000 plus 200. So just basically leaving y where it is. I'm moving the 200 to the other side. So we have y equals 200 r. Sorry, plus 1000. So we're going to be creating the IS and LM function in order to get the equilibrium rates and the equilibrium output in both markets. Yeah, I think I made a mistake. That's supposed to be 200 r, not 2000. So I'm going to be changing that 200 r, 200 r. Yes. Yeah, so that'll be 2000 equals 400 r. So to get the equilibrium rate, that'll be 2000 equals 4 divided by 400 r. So our interest rate, equilibrium interest rate is 5. So I mean, this basically means this equilibrium interest rate means equilibrium interest rates in both markets. The interest rate in both markets, like both the IS and the LM, which is the goods and the money markets, is 5. So here we're going to be getting the output for the goods market and output for the money market. And we should also know that our outputs must be the same for both markets. We have to get the same output for both the goods and the money market. So our LM is 2000. Our IS is also 2000. Yes. So I'm going to be explaining some other things before we um come to the end of the class. And we've basically solved this. So it is that's the graph. So we'll be plotting the graph. Yeah, but like this is just how it's supposed to look like since we're talking about equilibrium. So we need both curves, the IS and the NM curves in one graph. The other graph I've been drawing is just for IS and NM, but here we're going to be inserting both curves in a graph because we're talking about equilibrium in both markets. So for down part we have our output, then for the that's for the x axis, and for the y axis we have our rates. So to plot the graph, our equilibrium interest rate is 5, while our equilibrium output is 2000. Our output in both markets is 2000. So we're going to be assuming numbers. For the output, we have 1000, 2000, 3000, 4000. Then for the rate, we have 1057. Since we have our rate to be 5, our equilibrium rate, and we have our equilibrium output. So we're going to be joining both together. Yeah. So, yes, that's basically it. Okay. So then this is what we're trying to achieve. So our graph needs to look like this. So yeah, that's our LM curve and that's our IS curve. So that's what we're trying to achieve for both curves in this particular graph. So we need to have something like this at the end of yeah, at the end of this lesson. So yeah, I'm going to be showing you how to get that. So I'm going to be starting with the IS curve. For the IS curve, so our wife, as for the output function, the IS curve, we have 3000 minus 2800. I'm going to be getting the intercept. So when R is 0, we have our Y to be 3000. That's the Y intercept. So the Y stands for, okay, sorry, that was a mistake. The Y is basically for the output. Then when Y is 0, when that's for when R is 1. Then when R is 7, we have our Y to be 1 6. When R is 9, we have our Y to be 1 2. Yes, so we're going to be plotting that against our output. That's for the LM curve. Sorry, IS curve. So that's when our Y is 3. When R is 3, we have our Y to be 2 4. Then when R is 7, we have our Y to be 2 8. Then when R is 7, we have our Y to be 1 6. Okay, that's for one. When our R is 7, we have our Y to be 1 6. When R is 9, we have our Y to be 1 2. So we're going to be passing our IS curve using that. Now for the LM curve, we have our Y to be 1000, our Y output to be 1000 plus 200 R, and we have our R to be 3, R to be 1, R7, and R9. Then for when R is 5, we add 2000. So when R is 3, we are going to be calculating that. When R is 3, Y is 1 6. When R is 1, my Y is 1 2. When R is 7, my Y is 2 4. When R is 9, have my Y to be 2 8. So we're going to be plotting that against the output. When R is 3, we have our Y to be 1 6. So we're going to be plotting that. Now is 3 is 1 6. So after for where there's 1 6, yeah, then I'm going to be plotting that against. Then when R is 1, we have our Y to be 1 2. 1 2. Then when R is 7, we have our Y to be 2 4. 2 4. When R is 9, we have our Y to be 8. Yes, so that's our NM curve. So yes, that's basically it. So you always have to label your curves when you're done equating them to each other for us to know, oh, this is for the NM curve and this is for the IS curve. You can either write the names of the curve or write the equation for the market. So yeah, we're going to be moving on. So we can use the ISLM model to analyze the effects of fiscal policy, that's government attacks, then monetary policy for the money market. Fiscal policy affects good markets, while monetary policy affects the money market. So yeah, we've come to the end of our class. So if we have any question as regards this topic, so